In this lesson, we will discuss linear equations and word problems. Our essential questions will be, how can you define slope and y-intercept? What keywords in a word problem identify slope and y-intercept? How can we apply slope and y-intercept to our everyday lives? Our objectives will be to review slope and y-intercept, review those strong keywords, and introduce linear equations in word problems. For our exit ticket, we will solve a t-shirt word problem by writing an equation in y equals mx plus b form, identifying slope and y-intercept, and answering the provided questions. Let's get started. Let's recall y equals mx plus b is our slope intercept form of our equation of a line. We have seen this line on graphs and in tables. And then finally, we talked about how to write this equation using the graph from a graph or a table in slope-intercept form, where m is our slope, which we've also used the term rate of change, and b is our y-intercept, which we've also used the term starting point. We are also going to dig a little deeper and talk about other words that can help describe slope and y-intercept that we will begin to see as we work through word problems. All right, so our rate of change, or our slope, is something that's going to continue to change depending on something else. Remember, we talked about this being the change in y over the change in x, and how the y had a specific variable or a specific name, and our x had a specific name. And so depending on what happened on the y-axis, that's how we could determine the x value, so on and so forth. Or we can do it the opposite way. Whatever happened to the x value, we can figure out the y value. So that's why it's the rate of change. That's something that's going to change. One thing depends on the other, okay? We also talked about our input and our output values, or our input and output variables. Our x was always our input and our y was always our output. Let's write all of these keywords down. Okay. And then on our graph, when we looked at it here, okay, this is our x and our y. Our x value was always our independent variable, and our y was our dependent. So just these different concepts that we've already talked about. And all of this, we're going to combine all of this to make our word problems make sense. Now, we also talked about our y-intercept being our starting point. That does not change, okay? This does not change. Okay, it's our starting point. It's our beginning. It's what's going to be maybe a fee of some type, or a specific rate that does not change. Okay, so as we read through this word problem, we're going to see if we can identify which number is going to be our rate of change, or our slope, and which number is going to be our y-intercept. All right, we have a car repairman charges a flat rate of $100 to check out your car. He also charges $25 per hour to repair it. All right, let's look at our keywords here. Flat rate, a flat rate. A flat rate is not going to change. That means that no matter what this car repairman does, when you bring your car into his shop, you're going to have to pay that flat rate of $100. Even if he doesn't do anything, you're going to have to pay that amount. Once you pay that amount, he also charges $25 per hour, okay? So that's dollars per hour to repair whatever is wrong with your car, okay? So in this case, our flat rate will be our starting point or our y-intercept. So another key word for y-intercept will be flat rate. Okay, let's erase this so we can get a little more room over here. Flat rate. Okay, something else you might see would be fee. Say you're talking about going to a carnival or a fair. Sometimes you have to pay an entry fee, and then you have to buy tickets. So your entry fee may be $5, and then you may have tickets that you have to buy that are $1 each. So the amount you spend in total, which will be your Y in this case, will depend on how many rides you ride. Okay? So in this case, the amount the repairman is going to earn or how much you're going to pay will depend on how many hours he is working on your car. All right, so we got our flat rate of $100. And then as we just said, this will obviously be our slope because it's saying per hour. So another key word for slope will be per. We might also see every. We might also see each. Okay? So that's going to depend on how many hours this car repairman works on your car. So now that now that we have identified our keywords, let's go ahead and look at problem A. It says write an equation to determine the amount of money the repairman would earn, Y, okay, that's our total, based on the number of hours, X, he worked. That's our variable. That's what we don't know. But we know we can do Y equals mx plus b. And we now know that we can replace our m with our slope, which we identified as 25. We can keep our x there because we don't know how many hours, but we're just writing the equation that can help us figure out how much he will get paid in total. So y equals 25x plus 100. 100 is our y-intercept. That's our starting point. That's what has to be paid no matter what. Now, this is something that we've done before, but now we're going to take it a step further, and we're going to solve the problem when the repairman works for 4 hours. Okay? So, if I know the value of x equals 4, I can write x equals 4, and I can figure out my total, which is y, by plugging in that 4 for x. So my total, 25 times 4 gives me 100 plus 100. In this case, my y would equal $200. So if the repairman works for 4 hours, he will earn $200 total. Now, this can be done the opposite way also. If we're given a total, we can be given a value of y. Let's just say y equals 250. We can do the same thing and solve for x by just plugging in 250 for y equals 25x plus 100. Now we've talked about solving one-step equations. This goes on to solving a two-step equation and getting that x value by itself. However, we would use the same steps, we just do them twice. So let's just briefly look at how we would solve this problem using our steps. Okay, our goal is to get x by itself. X is attached to that 25, so I'm going to circle that whole thing. I don't want to bother that yet. My first thing would be to do the opposite operation. So I will subtract 100 from both sides, leaving me with 150 equals 25x. Positive 100 minus 100 cancel out. Now, my second step, once again, will still be to get x by itself. I'm going to circle that. That means I'm going to have to do the opposite of 25 times x, which would be division. So I'm going to divide both sides. Let's scroll down just a little bit. By 25, divide both sides by 25. 150 divided by 25, or how many quarters make $1.50, will be 6. Those cancel out, equal X. So in 6 hours, remember X would be the number of hours. This tells us that here. 6 hours will earn the repairman $250. So it works both ways. You can be given the X value and plug it in to solve for Y, or you can be given the Y value and plug it in to solve for X. All right, we've made it to our exit ticket. In the quiz following this video, you will answer these exit ticket questions. You own a t-shirt printing company. You charge a flat fee of $50 for creating a shirt design and then $10 per shirt that you place the design on. You will write an equation for how much money you will earn when you sell X amount of shirts, and then solve the equation for how much money you will earn when you create 10 shirts. All right, that's it. Take care.